Okay, so when we start talking about the characteristics of a function, it's a good idea to know what the function looks like. So type it into your calculator in y equals, and then let's take a look at the graph. Remember that when you're looking at graphs, good zooms are either zoom 6 or zoom 4 if you need to zoom in a little bit. So here's my zoom 6, and I'm going to pull that onto the screen so I have an idea of what's going on. So when I talk about end behavior, I'm talking about what happens to y as x goes to either extreme. So as x goes towards infinity, where does y head to? So if I look at as x goes to the positive end, y is going down. So I would say y goes to negative infinity. And as x goes to negative infinity, meaning moving left along the x-axis, y is going up. So y is going to positive infinity. All right? So that's our end behavior. When we talk about relative maxima or minima, okay, those are not the overall or absolute maximum and minimums. We have them a relative minimum here. And what that means is it's a minimum, but it's not the overall minimum. And we have a relative maximum right here. And so if you're going to be asked for those values, they're usually pretty nice ones, but there is an easy way to do that in your calculator. What we can do is we can use the second trace function. So if I hit second trace, notice how I have a minimum and maximum. I'm only going to do one of them, so I'm just going to find the minimum here. So I'm going to choose trace 3, and I'm going to scroll over. When it says left bound, I want to go to the left side of the minimum. Hit enter, and then when it says right bound, I go to the right side of the minimum, and I hit enter, and then I ask it to guess. And it tells me approximately where my minimum is. Okay, so we can see that there in our calculator. Like I said, if they ask for it, it'll be a nice value. Okay, degree of the function. Remember, the degree of the function is the highest exponent. It will be the leading exponent if you have it in standard form. So the degree here is 3. And I just wanted to point out that the leading coefficient in this one was negative. And what that means is the graph will end up going down at the end on the right side because it's negative. If it's positive, it will end up going up. Because the degree was 3, the ends are going in opposite directions, one up, one down. When it is an even degree, they either both go up if it's positive or they both go down if it's negative.